Testing. Check, check, check. Check, check. check, check. So, yeah, so sorry. I'm still not 100% recovered. So sorry for missing the Thursday. So, just updates of where we're at. Let me check here if anybody's on here. So, good morning. Come on in. All right. So, I am working on catching up. I got behind with some stuff. I did get back the assignment threes, so hopefully everybody saw that announcement. I haven't checked though because I asked quite a few people to fix a few general requirements before I would finish up the assignment three evaluations. So I haven't done a second check on that. So if you're seeing this and haven't looked at your feedback pull request on the assign the one before the one we just finished, make sure you go back and double check that. I'll try and get back to that today as well. I did get started on assignment fours, but I haven't got those back either. So question?
Yeah. So regarding, but do you want us to recommit to the GitHub itself or provide you the Python file directly?
It should be a new commit. So for most of the stuff when I ask to fix things, it can just be additional commit or commits fixing the stuff. So the most common one was just missing Python doc string, but there was one or two other things. So just in future, just be aware of that. Although I realized on assignment four, I gave you the doc strings again. So I'm sorry, I meant to. I'm not being consistent on that. I'm going to try and go back and change that. So from now on, people are kind of doing the functions from scratch. But anyway, yeah, just a reminder on that. I mean, there are some other stuff like make certain that you're using good commit messages. Make certain that each task is in a separate commit. So these are usually generally stuff that I won't take points off unless people are repeatedly doing this for all the assignments and not following the feedback and the code reviews. But and whenever I give the assessments for the assignments, there's a list of stuff at the top. So I usually have links. So if you haven't looked at that, the links about best practices for commit messages or for making commits or Python doc strings, you might want to look at those links that I give as well. So anyway, that'll probably be the last time I'll kind of mention those things. But to do, if you're if you didn't notice that I had gave some feedback for assignment three, check that and get that as soon as you can. I'm going to try and get that stuff finished up today, as well as also assignment four. I'll try to get those back as well here, so I can get caught up. Because for this week, also as a reminder, so we are basically just doing a test. There will be a test open starting on Thursday is what I was planning on doing it. I'm also a bit behind on my email, so I don't know if anybody asked to maybe extend that a little bit. I can maybe open that up a little bit earlier. I definitely can open that up, keep it open a little bit later, but at the moment I'll have the test open up starting kind of like after this class on Thursday. So you can do it Thursday, Friday. It'll probably be okay if you want to work it on the weekend as well. But I'd like people to try and do it on Thursday or Friday if they can. So I was going to talk about the format of that as well, although I'll get to that. But I thought, kind of as a suggestion, okay, so I guess I will jump into the format a little bit. The format for the test is not all that dissimilar from our assignments. So what will happen is starting tomorrow, I will make I will make this visible here. So starting tomorrow, the stuff's probably still hidden. But there will be a notebook. You'll want to download that before you actually begin the assignment. Although it's really just an empty IPython notebook with slots in there for the questions that you're going to get for the assignment. The only thing about this, if you want to download this, use it beforehand because it should have most all the imports you'll need for the questions. Although maybe not everything, so it will be fine if there are some stuff missing. You can add additional imports for stuff, but some of the imports that are specific for some of the questions on this test are in that notebook. So the format of the test kind of jumped into this here is it will be online, so we won't. I will have a meeting on Thursday in case anybody has any final questions. Although our meeting on Thursday might be relatively short. It will be online. Basically, what will happen is it will be a quiz. You'll get like 2 or 3 or 4 questions, and they're randomized, so you might not get the same questions as other people are getting. You'll have to start. It will be timed, so it's a little bit different from our assignments, but there's a 2-hour time limit. But basically, you'll get the question in MyLeo Online, but you should work on the code and the answers in an IPython notebook. And then the test itself should allow you to attach work. So attach like an IPython notebook to it. Although another question I often get on these is you can attach it to any question, but there's no need to have multiple notebooks. You can just have a single notebook with all of your answers for the multiple questions that you'll get. You can just attach it to the last question or any of the questions that you have. So it is fine not to attach something for every individual question. Just use a single notebook. I was the best thing to do for a review would be to go back and look at the first 4 assignments, probably after I talk a little bit about the test here, I was going to jump back and maybe talk a little bit about the assignment 3 and the assignment 4. Although I don't have assignment 4s back for everybody yet, or assignment 3s yet either. But I'd probably suggest that as the first thing to review. If you want to think about, so you're likely to see questions about just doing a linear regression, a logistic regression. There'll probably be a question that's more of starting just using Python and NumPy to start with. So those are usually the kind of stuff that I give with the questions on this first test here. So since the test is timed, I don't. The questions usually are going to be more straightforward than what we would have normally for the assignments. So typically it would be something like, I will give you maybe a data set or something, but perform a linear regression, and maybe do a plot of the resulting linear regression. So stuff that you should have done on our assignment so far. So yeah, looking over the first 4 assignments is probably a good place to start. But you want to make certain that you're kind of familiar with NumPy, using Python in general, maybe pandas a little bit. So the first question or 2 might be on stuff like that, and the scikit-learn library in general, and then doing linear regressions, logistic regressions. Maybe some stuff with learning curves. So there might be a question, do some things like we just did, using a learning curve or some other stuff like that. Okay, what else? So I will make that visible. So if people want to, I don't know if people can see that yet. I did just make that visible, but just do a little bit of review this week. We have covered quite a bit so far in this class, and do download that just before you actually begin your attempt on the test. it makes another thing I recommend. So this should work. The same environment that you've been using for the first 4 assignments is kind of what's assumed that you'll have available for the questions for this test here. So usually the best thing to do is just to reuse, like if you are using the containers, which I hope most everybody is using the class containers for the different assignments, you can just put this notebook into, for example, you're running assignment 4 container. That should have all the environment set up with the stuff that you need for it. That's usually what I recommend. But whatever you've been doing for the assignments, just make sure you have the same basic libraries. At least if you've been getting your assignments, been able to get the questions to pass and stuff like that. That means you probably have your things set up correctly with the right versions of NumPy and things like that in order to work on the questions for the test. So it should be expecting the same versions of libraries that we've been using for the assignments. Yeah, so I would recommend, just that you kind of have that set up beforehand before you start the test. So the only kind of big difference between this and our assignments is it will be time. So you will get a couple of questions as like a quiz or a test in MyLeo Online, but you'll have to then write the code or answer questions. I can't remember. There might be some things where I ask you to actually do some discussion, although most likely most of it will be coding. So using scikit-learn or using Python to answer different parts of questions. Using Matplotlib, there will be some plotting, stuff like that. Okay. So anyway, so let me know if there's any questions about the format on that, but be aware of that. That will be open Thursday and Friday. And let me know if people have some requests to extend that a bit. Like I said, we have in my email as well, so some people might have requested that already and I haven't seen that yet. So I'm trying to check that at least before our class on Thursday here, where we'll have like a final opportunity for people to ask anything if they want to. Although, I don't know if I have a lot to go over on Thursday. We'll see. So yeah, for the rest of the time today. Actually, maybe before I jump into the assignment 3 and 4, another thing. Let me kind of remind about the class project. So I did quickly look at that at the beginning of this week, and a lot of people haven't done any additional work on that beyond the initial commit to select some data. So again, on that, part of the evaluation will be some evidence that you've been working on that, continuously, incrementally. So not just all in like an hour or two in the last week, right? So I really would recommend some people start thinking about that, start making some commits and things. I'm going to continue to try and maybe give some things that we can discuss about that would make a good project. So the stuff I talked about before was setting up, make certain that you are using the environment .yml or the requirements.txt. Either one is fine, but do have your project environment set up correctly, so that if you are using so your projects are a little bit more open-ended. So, if you want to use something more specialized, so if you're aware of a library or come across something that looks like it would be useful or interesting to try out, that's fine. But just do make certain that you correctly set it up so that I can reuse your environment set up in order to get the same libraries and the same versions of the libraries that you're using. And because I do want to actually be able to not just look at your notebooks, but actually rerun them, run the code, make sure the stuff is running. So that's usually part of a project like this is specifying stuff so you can recreate, reproduce the results. It's not always easy, right? So this is kind of a minimum sort of thing. It's using PIP or the Anaconda mechanisms in order to create a virtual environment that has a specific set of libraries and versions of them. So we talked about that before. Usually for these projects, a lot of the work is done in notebooks, which is good, which is fine. Although a good project usually is gonna, sometimes people do it all in just one notebook. That's probably a minimum. Usually it's a good idea to have more than one notebook. So break those up into like maybe some notebooks about some data exploration. Maybe have some other notebooks about some cleaning work or stuff that you did. Maybe have some separate notebook, maybe more than one on like I tried this approach for a model, and then we got this result. So then we maybe try a second approach to making a model, see if we can improve performance. I might ask people, just as a heads up on this, I might ask people to actually do a little bit of a write-up. So actually come up with a like a document, although I might ask you to use Markdown for this. So the typical sort of final report for a technical project like this would have sections like like an overview, method section, results section, like a discussion, something like that. So I might ask people to do that, although I haven't given any specifications for that, so keep that in mind. But in general, for your notebooks, when you're using like an IPython notebooks, a couple things to keep in mind. A notebook is meant to be a literate programming kind of artifact. So that means it's not really primarily code. It's meant to be something that's read. So you should be making good use of the Markdown code. In fact, in good examples of like Jupyter notebooks, the code supports the narrative of the description. So I often, for these class projects, get a lot of notebooks where it's really just a bunch of code cells. There's no attempt to make a narrative or a story, make it readable for what you're doing. So keep that in mind. That's the real purpose of these IPython notebooks is you should be writing a document. The code supports that, so it gives visualizations and it gives illustrations of how things are done, but there should be descriptions. So learn a little bit about using Markdown. So in particular, use sections and subsections correctly. Notebooks should have assignment 4 here real quickly. Example here, or assignment 3. So I may not always do it real well on the assignment notebooks, but there's always at least some attempt to use the structure. So at a minimum, like our assignment 3 wasn't really all that great, but there was just a level 1 heading, and then everything else was a level 2 heading, a subsection for the different levels: introduction, task 1, 2, 3, right? So in general, so for notebooks that you're doing for a data analysis project, usually they will have a similar structure like I was just describing. So you'll have like maybe an introduction, and you'll have a couple of sections for, try this, and then maybe some kind of conclusion or something like that. So some organizing principle using, your markdown titles and stuff, heading level 1, level 2, level 3 headings, that kind of stuff. And there's lots of other features markdown. So do use basic stuff, bold and italics, and in my math and code, make sure you use those kinds of things. Also, all this stuff applies for assignment notebooks as well. So I still get a lot of people have their notebooks for the assignments where it's obvious that they're not doing like a run all cells to check everything out, especially for the last commit, where if you've got all the tasks completed, you should be thinking about, well, is everything working correctly? So usually these notebooks, and they do need to run linearly. So every cell should be able to run successfully. So if you do a run all, it should work, and it should be reproducible. So if you read some of the links I have in there, so when you're doing more complex projects, you might have some things in there that have some randomization, but in order to discuss stuff, you might need to set seeds correctly so that even if you are doing some random shuffling or something, you'll get the same results if you set a seed. So that's another good practice. So in general, what we're talking about here is the work inside of the notebook should be reproducible. So I should be able to rerun everything, and the discussion and every stuff should be the same. It should work, and if you're discussing stuff, you should always get the same results whenever you rerun stuff in the notebook. So anyway, that's something to keep in mind. All the imports usually should go at the top of these notebooks. And usually we do this in the assignments. So generally this kind of stuff like this. In the notebooks I give for class lectures and things, I don't always follow that because the notebooks themselves are discussions of using features from NumPy or scikit-learn or something like that. So we might import directly down in the cells. But if you're not writing a notebook that's a discussion or illustration using a particular library, a particular feature in a library, you usually want to have all of the imports up at the top, and then the actual cells and the discussions should be focused on the narrative for the notebook. So it should be focused on the cleaning or the analysis that you're doing. Right? So don't scatter imports around in your notebooks. And other stuff. So yeah, I already covered this. So you shouldn't be trying to install or setting up your environment in the notebooks. That should be part of the project. You shouldn't have pip installs, things like that in there. So, and there's other stuff. There's lots of other stuff in these 2 links if you're interested. Stuff that's not necessarily relevant to these projects for our class, but other general good things in there. But those are some of the kind of the main ones to keep in mind when you are working on your notebooks. Okay, so I just wanted to bring that up, and I'll keep trying to remind people about that. So keep nagging people to, do a little bit of work on your projects. Keep working on them. So we are actually past the halfway point on the semester here. So we've only got 7 or so weeks left to work on things. Okay. So still have plenty of time. Um, so I was going to move on. I was going to mention maybe just a few things about assignment 3 and assignment 4. And we'll see if there's if anybody had any questions about things. So, and for the assignment 3s that I did return back, I mean, usually there weren't really any problems. So everybody was doing fine on getting all these different parts here. If I ask for some visualizations on the tests or in these assignments, I mean, do try and follow some, at least the basics of creating figures. Should have stuff labeled. If you have components, if you have more than one component on a graph, you really should use a legend. Probably should actually, usually it's a good idea to always have titles, not only to label your axes, and if your axes have units, you should specify units on axes. Another thing, I mean, usually when you're plotting raw data, you should use points, but when you're specifying a model, something that's a theoretical fit, like a parametric model, whether it's a linear or nonlinear model, you should use a line for those things. So the difference being, so these are the actual data points that were measured. I mean, this was just somewhat made up data on this assignment 3 that we just finished. But when you fit a set of data there, so when you actually have a model or hypothesis, it really is, for every potential point, there is a prediction or a hypothesis, right? So it is continuous, unlike where data points are. So we have 47 data points on here. So in general, you should reserve points in a plot. Raw data, but always be showing models as a continuous line. So I'm trying to add, if I had like, I mean, the ones that I had checked, people have gotten all these things correct. I think, like visualizing the loss function. So what else? Look at here. Also, I mean, I didn't think anybody had any problems on the gradient descent. Bring up so. One big thing was that I had to return back and ask people to do the Python documentation. So if I don't give this to you, future assignments, I should have a little bit of that. You should use the NumPy format. So the basic NumPy format is a sentence or more description, and then you document your arguments to the function, usually in this format, so the name, and then some idea of the type or other additional information, then also some more sensitive description, and then the return value or values also should be documents. So the NumPy standard for Python documentation looks basically like in this format here. So anyway, looking at the loss gradient function, or the gradient descent function, is where I was at. And I don't think anybody needs kind of the example solution, but if anybody wants this, let me know. I can make available the example solution if you want to compare if there's a question more specifically you had about something. So, but yeah, the gradient descent, like we talked about for this task here, is easiest. In fact, I don't know if it's really worth trying to vectorize this. So just having a loop that does it for the fixed number of epochs in this case here. But yeah, most people have pretty much the same thing or very close to this. The only maybe real difficulty was, just correctly doing history like was asked for. So, you could do something like in this approach, like I think was described in the assignment. A relatively easy thing to do is just to append things onto a regular list. And then just since the assignment was expecting to go in an array, just convert the list to an array and return it. You could just use like a NumPy array and then some manipulations of NumPy array to add. Well, I think one or two people did that for the ones that I returned. Okay. So yeah, I guess so I didn't have a whole lot of other comments on the assignment 3. So let me know once I get these back here. There was a specific question people had on assignment 3, and let me. There's probably a little bit more we could discuss on the assignment 4 here. Like I haven't got this back to everybody yet, but I am in the process of getting the assignment 4s returned to everybody. Bring this one up here real quickly as well. So while that container is being created, so I definitely maybe should post this here. So in fact, for this assignment that I gave you, the parameters, it was actually a 6th-degree polynomial for this assignment 6 here. And we're using those set of parameters. So basically just whole integers, 2s and 0s and 1s, plus some noise on that. So the parameters weren't very big, and we dropped a couple of the terms. So we used 2, -2, 1, and -1 for a couple of these here. Right? So that hopefully that's the same one I gave you. It should be. All right. So so the true function was actually that. So it wasn't 2 nodes that we given you here, but the true function was a degree 6 polynomial on this. So yeah, I mean, you might be interested, depending on how you did. Let's see if this is finished yet. I'm still going. So like at the very end, for the interested student, like the very last task, where you like did a grid search, you might be interested to, or even before that. So when you estimated the parameters by hand using lasso, the other kinds of regressions, it is useful to actually compare the results you had with the true function, the true model was generating the noisy data, right? Just to get a feel for what's going on. So I'll jump in and discuss some of these in a little bit more detail here in a second, once I get the notebook loaded up here. But when you're doing a real data analysis like this, and trying to fit a model. So here we were fitting a nonlinear model, right? And when you were doing the assignment, we're supposed to be doing it without actual knowledge of what the true model was that was generating the data, right? And that's the way, whenever you're doing a real data analysis, that's going to be the normal state. You won't know even, whether the model is nonlinear or not, and what degree, like in this one, what would be a good number of parameters to make a good fitting model. In fact, in real world data, there may not really even be, a truth out there, right? Depends on how the data is being generated. Not to mention also, the noise was relatively small on this, so for a real data set, the noise might be much more of a bigger problem, obscure what you're trying to fit or trying to predict that you're working on. So yeah, I really like this assignment 4. It just gives you kind of a good feel, especially when you go back after you finished it, kind of compare what you were thinking of at the time to what the true polynomial was, the data we had, to see kind of what was happening with your underfitting and your overfitting. Okay, so I guess I'll continue using this notebook here. So if you did the first task as was asked for in the assignment 4 here, where you fit just like a line, a degree 1 polynomial, is that what we asked for here? A degree 2, the quadratic model on this one here. You should have found something pretty much like this, if not exactly like this, so that you get, what was it? About a 0.3 or so on the root mean squared error in that range here. Right, and then, so like I said, I haven't had a chance to look at a lot of these. If you plotted the learning curve error, if you created your function to plot these learning curve errors, you should have been getting something like this for the underfit model. So again, what is relevant about this is that there's convergence. So after a bit of time, once we've got enough points that we're using to fit the model, we're getting roughly the same performance for the loss function for both the data that we trained it with and the data that was not used in the training. So that's the test or validation data that we plotted out here. So this should be giving you kind of a baseline that, I definitely, if I can get a good model that is converging, that is modeling its data, I ought to be able to do something, but hopefully get a better result, so a lower loss than what this underfit model is. So if you're doing this for real, like in a real data set, you often, the usual advice is to start by getting a model that converges like this. So if you look at learning curves, how we generate the learning curves, you want to know that the model is doing something, because when you train it, you're getting roughly the same performance on held back validation or test data as you're getting with the data that you actually train. So as a first step, you usually want to start with an underfit model like this. So you can, so when you're first starting out, you might not be able to get convergence like this, right? So if you're not getting convergence, you want to actually simplify your model, make it less and less parameters until you get to some point here, which is probably underfit, where you're getting approximately equal performance your training data and your validation of your testing. So yeah, if you look at the, so you wouldn't have been able to do this, but you performed the underfit model. It's a degree 2 a quadratic, so would have gotten basically pretty much this, the similar or the same model here. Right? So the underfit model is just underpowered for the polynomial for the set of data that we're trying to figure. So then what you should have been getting for like a degree 100 polynomial, and here I know that one kind of thing that I usually get feedback on is a lot of people don't limit the axes when you show the learning curves here. So finally. So, this one here. So in this example solution, we were kind of limiting the y-axis here. Can't remember if this notebook takes a long time or not. We run everything above this here. Too bad. All right. So the problem with this, so with the visualization like this, if you don't limit the axis, it's not really useful, right? So because the root mean squared error on the test data diverges so much from on the training data, you're not limiting, right? So this axis is actually scaled up to tens of millions. You can't really read it off directly. So the important thing on this is we want to know, about scaling, you might convince yourself, well, it is converging here. But we really need to see kind of what's happening down in this range here, especially at the start here. I mean, is this really converging or not? And really, I mean, immediately, if you look at that, let's increase that to like 10 here. I mean, it's very clear that it's very quickly diverging, even right at the beginning. And it never gets back to being close. The validation, the test performance never gets back to being close. And again, this is typical for a learning curve where we're overfitting. So we do great on the data that we train with, but performance is just terrible. So again, without limiting that, it's hard to estimate. So another thing, the reason why you want to get an overfit model, that's usually your second step when you're analyzing an unknown data set like this. That's usually what's recommended. is you'd like to get a feel for where does the test data actually converge at. Sorry, the training data. So what is the performance of the loss function for the training data? Because a well-fit model, we ought to be able to get about that same performance, but on unseen data. Same kind of loss level that we're getting here. So in this case, that's implying that we ought to be able to get, instead of 0.3, we ought to get a loss down to around 0.03 if we have a properly trained model on unseen data. Or if when you did this one, probably you couldn't get quite down to that, but typically you get down to about 0.04, 0.05 using good parameters with the regularization. So anyway, so that's usually the purpose of kind of trying first getting a model that is probably underfit, but at least it's converging. That can give you an upper bound, and then you want to usually try to get a model that is definitely overpowered, right? So you know that it's doing something, but it's very bad on making predictions on unseen data. So validation of test data here. It's no longer conversion. It's definitely more overpowered than the underfit model that was conversion that we had before. So again, you wouldn't have been able to do this on the assignment. If you have the actual true function, you can compare. So typically what you see for an overfit model is, especially on the ends, this kind of polynomial fit that we're doing here. It's making very large excursions. So this is most of the source of the error, the stuff down here near the bounds. So whenever we're trying to calculate loss on validation data that doesn't have to be exactly one of the points trained with, we're going to get very large differences between the predictions and what the actual function is. Yeah, I was just going to show. So for all I don't think, again, I haven't looked at a whole lot of these yet, only a couple. But yeah, I mean, most people were using the pipeline like you were supposed to. But I mean, most all these actual for the tasks were pretty similar, right? Just creating a pipeline, putting it through the asked for polynomial features to get the right degree, and then either using a linear regression or using lasso or something else. So, so for the overfit one, it was basically the same, but upping the degrees to 100. And then for lasso, it's basically using a lasso, so linear regression, specifying different parameter, different values of alpha by hand. In this case, we didn't actually pass it in the task 5, task 6 function. But yeah, besides those two different things, you could have solved most all these tasks pretty much very similarly, and that's what most people did. Usually, the ones I looked at. So. So if you have a relatively good value for the lasso, remember the lasso so for task 5 here, is doing the L1 regularization. So this one, right, so this one is doing having the penalty term that's the square of the parameters. No, sorry, I got that backwards. So this is the one that's really the square root of the absolute value of the parameter. This one tends to drive the values to 0, right? That aren't useful. Right? So if you have a good value of your alpha, you might have been able to estimate what the polynomial was. So yeah, so in this case, we're using from my code here. So for the lasso, we're using, it ended up having to be relatively small in order to get a good one. So you have to get really close to 0 or, but anything kind of 0.1 or even 0.01 going to be a little too big. I remember. But yeah, if you were doing this by hand, as was kind of asked for, you should have been able to find something in there where a lot of the stuff that was bigger than, again, the polynomial was actually degree 6, but it would be tough to get an actual one that gets it right down to everything except for 6. This is the 0th degree term, and so this is the 1, 2, 3, 4, 5, 6. So this one, the one that I'm showing here, goes up to about 10 or 15 terms, and then everything higher than that, it's effectively driven to 0. But yeah, again, if you could look at your true function, you would see that this ends up being giving you can get some things that are beginning to look close to the actual functions generating this data, just using a bit of L1. And then Ridge is using the L2. So this one doesn't tend to drive things to 0, but it will actually get you a simpler model. So you should be able to get a similar thing using, in this case, like an alpha. So in this example solution, we're using alpha 0.01, so a bit bigger than what you typically have to use for the Ridge. Check for the last task. Right. So I think I skipped over the this is what you should have seen for your learning curves if you were getting good parameters here when you did them by hand when you're doing the regularization. So again, we need to scale your axes in this case because they are pretty much similar. After about 10 or 20 points that we fit our model with, we'll get similar performance on our held back data. That's the data that we train with. Right? And we're converging at a much lower level than we did for the underfit. So again, probably wouldn't be able to get all the way down to 0.04, 0.03, but trending in that direction with an appropriate value for your alpha recommendations. So yeah, this other one, even though it doesn't drive the parameter to 0, it usually does give you an actually superior model if you're looking at it, except for maybe at the very extremes usually. Okay, so yeah, we're coming kind of to the end of the class here. So the few people I looked at, hopefully everybody did actually do some discussion here. Right, so this is the only kind of place where I asked for a little bit of actual written discussion. And I was kind of looking that you gave me at least a little bit in the table here where you kind of showed me when you were doing it by hand, something that was too small, something that was too big, something that was kind of in between, and what you were getting. So typically you should have gotten much higher root mean squared errors and lower R squared errors if your parameters were not in the right range for the alpha, the last ridge. But yeah, you should have had, hopefully had something around in that. Didn't have to be exactly this when you're doing this by hand. Something relatively small for lasso, something around 0.01 or so is usually, for me, giving relatively good root mean squared error loss. So just as a final thing then, hopefully everybody did get up through the final task 8. So you might want to keep this in mind when you're actually working on your own project. So usually you want to be more systematic. So when you know what you're doing and you have some idea of what meta parameters for a model that I want to fit, you might want to more systematically search a range of values, right? And I definitely should post this here because this does some stuff. Can't remember. It did pretty much kind of give you this at the end, right? So this typically, this is only specific to the assignment here. So our secret function was really using this polynomial. So the very best thing you could do was actually have a model that had the correct polynomial degree, right? So instead of using the ridge or the lasso regression with the appropriate value of alpha, if you kind of knew what was happening here, we ought to be able to get a really good model as close as possible if we could figure out the exact degree that we want. It is possible. So if you did this correctly here, this was mostly to try and illustrate the power of using the grid search. Right? So we set up a grid search when we pass in. So we're going to be trying all of the different degrees from 2 to 100 in this case, and see where we end up with the best here. And it will usually get exactly the correct answer here for whatever the secret function. So you do a grid search on this. We had to do, in this example here, we had to do, pass in a dummy function here that would actually create a pipeline for the number of degrees, then just using a linear regression with no other parameters ever set. So that's kind of what's being done. But this will give you, since we kind of know that's what was being done, this will give you a really good result. So again, if you compare the parameters here to the secret function, so these were the actual parameters that we've been using in that secret function. So 2, 2, 0. Again, there's some noise, so you'd never be able to exactly recreate it, but by being able to estimate the polynomial degree, you'll get a really good fit, including also this gets rid of the problems even on the extremes of your range here. You get with the ridge regression. Okay, yeah, so that's it for today. I'll go ahead and let you guys go. Let me know if you have any questions. Those are good things to review, though, the assignment 4 and 3. Those give you a good start on thinking about what you need to know for the test. So we'll meet again on Thursday. It might be a short session in case just if there's any last questions on the test and stuff. But All right.
Sir, I just have one question.
Yeah, sure.
You just told that you will review the data set we have used for the final product, right? So are we good to go ahead with whatever we have provided? Or
Yeah. So if I didn't ask you to change something else, assume that I was fine on that. So, yeah, if I did give back.
Yeah, so I was just
Yeah.
curious.
Sure.